Hello, everyone. Thank you so much for joining. This is our first kickoff meeting. GDG Web Stockholm officially started now. My name is Morteza. I'm a senior software engineer at H&M, and I am one of the organizers for GDG Web Stockholm. I have three more amazing organizers with me, and you will get to know them soon. I was thinking to actually have a group photo, but it seems that we are not able to do that. I'm not sure, maybe this is a lack of my knowledge with this platform, but at least we have you. Cool. Let's start by let me try to move to the next slide. Yeah, so maybe you ask, like, what is GDG? GDG stands for Google Developer Groups. So it's a global community for developers, designers, and also tech enthusiasts. We currently here in Stockholm, we have three groups. We are the latest or the newest, I would say. And the other two are also for Android and cloud, if I'm not mistaken. So GDG goal is to build a community, to learn, grow together, and also share the knowledge between us through like workshops and also networking and having blog or something. So since it's a community, everyone is welcome, whether you are a beginner or you are an experienced engineer or designer. This is your place to learn new things and also to share your knowledge about any topic that is interesting for you and also other people. About our chapter is like the name is GDG Web Stockholm. It's related to everything on web. It can be like JavaScript, all the UI or front-end frameworks, performance, cloud, AI, anything like is related to a web somehow. And if you want to give a lightning talk, just go for it. Ping us, and then we can have we can invite you for the next event. Or if you have a cool project, just demo it here, or just share it in the chat, and then let's people discuss it and share their opinion on it. Or if you have an idea for the event, just reach out to us, and we will invite you for sure, and we will learn from you also. Okay, so before going to the next slide, please say hi in the chat. Let's warm it up. Tell us where are you living, where you are coming from, what is your job, if you are front-end or anything. And also, this is really important, share your favorite programming language. I know it might be JavaScript, but feel free to share your favorite one. So while I know you are typing now, you are typing what is your favorite language, but let me introduce other co-organizers. We have Sahar, which is our awesome digital marketing manager. She helping us a lot in social media, how we should promote it, and all of social media posts that you see is coming from Sahar. Then we have Zohre or Zoe. She is one of the amazing software engineers that I know, and she is currently working at PostNord. So really nice to have you also. We have Meghdad, which is also one of our speakers today. So he is also a software engineer. He's a really old friend of mine. I learned a lot from him, and hopefully we learn today also. And also myself, as I told you, I'm a senior software engineer at H&M and also one of the co-organizers. And also we have Vinicius. He's one of our speakers, which we will learn a lot from him regarding like performance and like AI agent. I don't want to spoil anything. We will see it soon. Cool. So let's go to the agenda today. So we already have done the check-in. We are doing the welcoming and introduction phase now. And in 4 minutes or maybe earlier, we will start with our first talk, which is regarding performance debugging with DevTools and AI assistance from Vinicius. And then we will have a QA session. You can ask all of your questions here in the chat, and we will ask Vinicius, or he also can see them and he can answer them. And then we go for a break, 10 minutes of break. Just grab a tea, grab a glass of water or anything you like. And then we will continue with the second talk, which is about creating an AI bot. And that is amazing talk, I would imagine. And then we will have like 10 minutes of finishing timeline that includes one survey, one of these Menti interactive type of questions. It's coming from another platform. It's not Menti, but we will love to hear from like your feedbacks from our event. And if you have ideas you want to share with us and anything related to that. But just so stay tuned. That would happen at the end of the event. Cool. Now I think we can start maybe a bit earlier, and I can pass it over to Vinicius. Please feel free to steal my screen. I can take it back.
Yes, I will be stealing it away
Yeah.
in just a minute.
Feel free.
Yes, so I'm going to set a timer so I don't get lost on the discussion, because I am this session I've planned to be more like a walkthrough. So I'm going to be showing stuff, and I felt like it would be a bit too distracting if I jump between slides, so I ended up not preparing any slides. So it's going to be very hands-on. So buckle up. My name is Vinicius. I am a lead engineer, front-end engineer by day, but working with AI and performance every other time, pretty much. So my online presence is mostly revolving around the latter. I'm building a set of tools using a fork of mine of Chrome DevTools to generate insights, performance insights, and analysis for non-specialists. I wouldn't say non-technical, but like non-specialists and teams, web team development teams in general. Because one of the biggest problems I see is on how to read performance data. So that data, normally performance is a very steep vertical. The data is normally very, very terse, very difficult to pass for non-specialists. And we're going to go through different stages of that on this walkthrough. I'm going to show a little bit of workflows directly into DevTools, and how things can take shape for a more, let's say, agentic workflow. And I promise you, this is not going to be the last time you're going to hear me saying agentic. So let's take a look. So can I present? Is there more? I think I have to get permission to present. I don't have share screen permission. Can you?
Let me check. You should have access, but let me see. Now you're on mute, Vinicius. I think something happened.
Yeah, it muted me, but I still don't have the
Okay,
share screen.
let
me
me
try to rejoin. Let's see if that works.
Yeah. Okay. Cool.
And
Yeah, this is like always happening when you have something live. So unexpected. Let's wait. You're on mute.
okay, now I am. I still don't have a share screen option. That's interesting.
Now?
Oh no, now I have.
Okay, so I had to
Okay.
stop. Sorry.
Interesting. Okay, now I have the sharing option.
Yeah, perfect.
Okay, so let's take a look now. Then I am going to share the whole window, the entire screen. Better. There you go. All right. Sorry for the infinite mirror effect. So I'm just going to take a look now. First, I'm going to take a quick look at. Let me pop this up into its own screen. So there. So let's take a look at how a trace would normally look for anyone reading. So I ran a series of tests, and we can talk about the results later. So let's take a look at just a regular trace. How does a trace look like? So some of you, this might be the first time you're reading this, hopefully not as many, but I've seen that there are some students, some fresh junior devs and stuff. So this is how a performance trace would look like. So whenever you record a trace on the performance panel for the DevTools, you would see something like this. So you have the like some form of activity timeline with the overall activity thread, how the main thread would look like, and different colors mean different things. So yellow means normally JavaScript running. You have underneath that you have the screenshots. So this is screenshots that are taken as you record the trace, as you interact with the page and stuff like that. Then some other, as we call, lanes, so network frames and etc. But let's focus on the main thread lane. So within the main thread lane, you have these guys here. So they are the different tasks and events that happens within a trace. So those are called icicles, officially speaking. So they will represent top down how different things happened and when. So you have the duration of a total task. So this was also followed by a pointer event. So you have within the interactions track here, if it was executed due to a certain interaction within the page, you have it within the interaction. If it was
Vinicius, sorry to interrupt, but could you please zoom in a bit?
apologies. Yes, I can.
Yeah.
Is this better now?
Let's see if
Is it better?
It's better for me, but let's check the.
I'm gonna do one more. There you go. See, this probably is better now. So within the interactions track, you have interactions, and underneath on the main thread, you have whatever series of events that happen due to those interactions. So we have at the very top, you have the main tasks. So the tasks is just like what overall happened. So within each task, you have series of events. So you have the click event, run microtask, function call, different functions that comes from different sources. Each source is properly color-coded, so you can easily spot them. So for instance, anything coming from client.development within the bundle are in this light of shade of blue, and anything coming from the page.tsx comes on this shade of pink. So you can easily spot them as you're debugging through the different parts. So one of the things that is important to differentiate when reading a trace is what matters is not how deep it is, but how wide it is, right? Because the width is the timestamp, is the time span. So the longer in width it is, the longer it took to execute, right? And any task that there is this like red little chevron, it means that is a long task. So as you can see, when I hover over, it says it's a long task. It took 143 milliseconds. And the definition of a long task is anything that is longer than 20 milliseconds. So this very, this very quick, very short, very fast, welcoming to your very first experience with the performance trace panel if you've never seen it before. Now, what is cool is that the Chrome team has been working on trying to help people better understand things. So if you're a novice, normally you wouldn't be able to tell what's going on here and why do you need to focus on anything. But now you have this insights panel right here. So if you open the INP by phase insights, so INP stands for interaction to the next page. So this is a metric within Web Vitals that has to do with interactivity, and it tells us that our interaction. So you see a pointer event here. It has different sections. So we have within the INP, we have the input delay, we have the processing duration, and we also have a presentation delay. So we can see here, it's very clear to us that processing duration is the longest time within the 3 segments. So this is our biggest focus for INP fixes. And even within here now, as you can see, we have this Ask AI thing. So let's see what it does for us. So this Ask AI here, it has some suggestions for prompts that you can do. And it will say, okay, maybe I can suggest fix for the interaction. And within Chrome, you now have access to an AI chat of sorts where it can tell you, things to do and what does things mean, what does things means, and how to optimize, your execution for this particular trace. So those are very helpful and nice. Now, the thought exercise here that I have is now with the age of vibe coding that, we are democratizing the so people can build things. What would it look like this step to also be baked in within this process? So let's take a look. I have here downloaded, let me minimize this, close that. So I have downloaded here a few things. Let me open, where is my, oh, there you go. This is my terminal. So I am going to run a few things here. So fret not, just I'm gonna run a sequencer. So this I generated with V0. It's just a regular V0 project. So if I go to v0.dev, is this guy here. So this is one of my test runs. So pay no heed to that. So it's just a simple step sequencer that I generated within V0. So not much happened here. But I did that so as to test the premise, right? How would it look like for this sort of workflow be agentic and, allow people from any sort of knowledge to do things with an agentic workflow with the code generation and automated insights. So with that in mind, I am going to now start my MCP server. So for those who never heard of MCP, whilst I do this, MCP stands for Model Context Protocol. It's one of the tools that an agent can use to make calls for things that it would not have access otherwise. So it can be for like literally anything. It can be for a different agent that does cart access for you. It could be for a different service altogether. And in this case, I created one. So I forked DevTools and I embedded an MCP service inside of DevTools. So I'm starting an MCP server here. And with that, my code generation tool, so be that Claude, be that any MCP capable code editor, or even Claude Code, if you use Codex, Gemini, anything that is an MCP client can use DevTools to better understand performance and generate fixes for that. So let's take a look at that. So right now, I am going to run a trace. So if you never run a trace, it's always very important if you're running a performance trace in this case, always slow down your computer CPU, because those I'm running on a very the latest M4 MacBook Pro. It's very fast, won't give you the best possible scenario for a realistic performance trace. So 4x slow down.
I sorry to interrupt, but could you please a bit like zoom?
Oh yes, of course. This is also zoomed out. Very well reminded. So So I'm running with 4x slowdown. So again, as to mimic a more average device out there. So 4x slowdown network for 4G fast is kind of the standard to run trace. So I'm starting a record button. Now the trace is recording. So I'm just going to click around and see what kind of metrics do I get. So just clicking and stop. Nothing really fancy, but this code is entirely generated. So the purpose of me generating this code is I wanted to see what it looked like for a code that's generated. How does the performance get, what kind of performance do I get out of the box, straight out of V0? So this is just downloaded straight out of V0. So I have INP on 201 milliseconds. So as you can see, the INP is orange. INP in every core Web Vitals metric, INP is one of them. LCS and CLS is another. LCP and CLS is another. They have different thresholds. So they have a threshold for needs improvement, for good, and for bad. So in this case, it stands as needs improvement. I have 155 milliseconds total processing duration as it stands right now, straight out of V0. So this now it makes me believe that it could be better, right? So let's take a look at how much better can it be. So now I'm going to go to cursor. I'm going to close this, close this, close this. And now I'm going to open a new session. So, and a fresh new session. I'm using GPT-5 High. This is standard within cursor, so we have access to that, and you can also use Claude, whatever model you would like. Any model that is good at running tools is good at doing this. I also have the MCP server. So I have two different servers. I'm going to get into a second one just in a moment, but I have my DevTools MCP server right here. So with that in mind, I have a bit of a pre-planned prompt. So normally prompting models, prompting in general takes a little bit of try and error. So I have here, let's see, INP test. I'm going to use the retest here. So as you can see, I've run this several times just to make sure what kind of model works best, because normally there's a little bit of try and error on this. So I have a very simple prompt. Let's ask DevTools for INP insights on the trace I just recorded. No need to record a new trace because I have another tool to record trace and I don't want the model to get confused on that. Just ask for animation frame insights. Alongside it, use the call tree analysis is another tool. So as you can see here, maybe I need to raise this font size as well a little bit. So I have three tools coming from my DevTools MCP. So I have record trace, get insights, and call tree analysis. So call tree analysis will analyze the call tree itself. So this is a call tree. So it will analyze the call tree for different event durations, see where's the bottleneck. Get insights it gets this kind of insights right here on the left. So we get this kind of insights from DevTools. And we'll also use the get insights uses the model within DevTools to get the insights for me. So just get this information from me and let's see what the model will have. So now GPT-5 is very verbose. We will kind of like have an internal monologue. What should it do? What kind of things will it get? So it's kind of like monologuing to itself, planning the moves to do. So it's discovering my MCP tools and saying, okay, I have access to this and that tool. I should call this and that tool. And it will finally come here with a prompt for what tool it will call for me. So GPT-5 is quite verbose on this stage, but it finally called the get insight, called the call tree analysis, and it will generate a report. As it generates the report for me, let's see what did it get from those tools. So out of those tools, it got from the insights here, it fetched from the interaction, and this is what it got from my MCP tool straight up inside of DevTools. So this right here is what we call a chain of thought prompt. So what happens is that GPT-5 has no idea what INP is. I mean, it has some idea what INP is, but it has no idea what a call tree is, has no idea how to fix problems with performance per se. It's a very generalized model. It's a large language model. It's trained in a lot of stuff, mostly language, but it doesn't know how to fix performance. So with that in mind, what I'm doing here is giving GPT-5, or any model for that matter, a chain of thought prompt. So I'm teaching it, okay, you'll be provided with a text representation of a call tree. So it comes from JavaScript call frames. I give it a little bit of background for what is going to be given, give it a little bit of background of what is the format of the different entries that it's going to find, key definitions for each one of those entries. So an ID, a name, duration, self-time. So give it an objective. So your objective is to provide comprehensive analysis of like what kind of information would I want it to have based on functionality, execution flow. So I'm teaching it how to analyze a call frame. But, call frames are very extensive JSON data, so I have to do a little bit of a parsing. That's why there is this custom format here. But in general, the TLDR is I have some guidelines, I have some things that I wanted to do, and then I give it a little bit of an example because it's a chain of thought prompt, right? So it's just teaching the model how to think about these kind of things. And then an example response. So what kind of things would I be looking to get out of it? And then here's the actual call tree analysis from the interaction event. So I have a bunch of different sources where the events are coming from. And I have, a whole bunch of calls that are happening on that call tree. So all this data is very terse. You don't necessarily have to understand this. Then on the second one is the same but for animation frame, again, a chain of thought prompt. And then the third one here is what is the interesting one. It comes from the model baked inside of Chrome DevTools itself. So this one is kind of like a digested information. It's not necessarily telemetry data as GPT is getting from this one, but it's just the model within Gemini telling what it thinks it could be the problems based on the event it was selected. So I like within all of those calls, what I do is that I look for which so it has two different searches, right? So in this case, longest animation frame, but it also has animation frame here, and it has the interaction. So based on the search I'm trying to provide, I'll check the trace file that I have in context, and I'll search for the relevant events. So and give either to Gemini or give so it can give me a message, so I can pass it back. In this case here, or the chain of thought prompt. So GPT can understand. So based on that, GPT now understands what's going on. So it says, okay, INP interaction insights took 158 milliseconds. The click event is 155 milliseconds. Out of those 154 milliseconds of microtasks. So the dominant work is React render commit. There's a lot of work being done by render loops, and that's where I'm spending most of the time. So extra overhead, etc. So, but this is what is the most interesting for us, right? Like, so if you come here, 155 processing duration, this is where we spend the largest amount of time out of 201 milliseconds. So right now, GPT understands what's going on. It knows what files. Sorry, there's an ambulance. I'm not sure if microphone is speaking. But GPT right now knows what is the problem, where is the problem, what files are relevant, and what kind of fixes to do. This is kind of like everything we want, right? As a developer, this is the kind of things we would be reading a trace for, the kind of clues we would be getting as a specialist. And this is now where things get interesting. So I have this V0 MCP, another MCP server of my own. So I've built an MCP server on top of V0 SDK to have access to V0 itself. Let me open I have a clean slate of this. Let's see if I find music composition tool. Yes, this is the one right here. I'm going to make a fork out of it. So this is like a clean slate. So because I had a lot of different tests, and I want a clean context, so V0 doesn't already know, because I had ran so many tests. I want like a clean slate. V0 knows nothing about what I was trying to test or anything as such, and it will be just like a entirely clean canvas. So live session fork. Boop. So with this entirely clean context, absolutely nothing happens. V0 doesn't know what's going on. I'm going to get this ID, and I'm going to now tell, okay, we seem to have INP problems. Let's now get those insights. Actually, better yet, instead of typing, because we're almost out of time, let me just copy okay, I have a prompt here that I generated. Is pretty much what I was going to type anyways. But then within this, I have just to update my ID. So it's a very simple prompt. It seems that the INP insights, because I already knew the INP was a problem. So it seems that the INP insights data seem to be where we can focus to improve. Use the insights you were given, relay the information to V0 so V0 can fix the problems with its own coding agents. The starting question is of this ID. Engineer. So I'm thinking, because we're using this kind of like raw data coming from the chain of thought context. So I'm telling GPT-5 now, using your own capabilities, engineer a chain of thought prompt so V0 can, get the best benefit. So context engineering itself is an entire different talk. We can spend a lot of time talking about this, but just know, so it's just a way to avoid the model going to different tangents. So with that, we're going to now call this. Now GPT-5 within Cursor, it could be directly in Cloud Code. It doesn't even have to be within Cursor, because right on this session here in Cursor, I'm not even looking at any repository whatsoever. So in here, I'm just saying, all right, now relay that information that you just got from DevTools straight into V0. V0, as you may know, is like lovable, and it is a coding agent of its own where, it generates interfaces and applications. So now GPT-5 will get the results out of DevTools, hand it over to V0, and V0 will get those insights and fix our performance problems, hopefully. So let's take a look at how that goes. So it now is calling that. So if I come here, hopefully I'll have a message coming through anytime now. Let's take a look. And now it's going through my own server, MCP server, that will relay that information over to V0, and then V0 will try and fix this data. Unless my session expired. Let me see. Let me watch for that. Yeah, my session kind of expired. Let me take a look. Let me do that again. Hang on. Stop. Log out. Connect. And log back in. Back into Cursor. All right. I refresh my session. Now let's run that again. Is it the right site? Yes. This is the right one. X1 final. Yes. So let's try that again. I have some pre-ran sessions just in case something doesn't work, but let's give it another shot here. And we're pretty much on the last segment, so we'll wrap up soon. So unfortunately, GPT-5 is kind of terse on this part, so it will think for a while, and then it will call the tool. I refresh my MCP token because this is like a authorized MCP, so the session might, gets there and expire, which is what happened to us right here. Just trying to plan the next move again. And this is the thing with doing things live. Let's resend this. Planning next moves. Don't disappoint us, GPT.
Yeah, this is always happening. Like it's quite normal.
Yeah. This is the thing where, okay, there you go. Now it seems to finally pick up. Planning shouldn't assume too much about the file structure, just the names of seeing. Yes, exactly. So again, it goes through like the monologue because it's a thinking model. It will do a lot of internal monologue to, reassure itself of what it needs to do. And then it says it wants to do a diff-based PR. Hopefully it doesn't, but let's see. Requesting code fixes. Okay, it's calling the MCP tool. Let's see if this time around it will find, but I have some sessions that happened prior to this, because as we see, these things sometimes have hiccups of their own, and we don't, unfortunately, don't have time for more than a few times. Okay, this time it seemed to be managed to get the message through. Let's take a look at the message arriving here. And it should arrive here in any time. There you go. So now it sent a message here to V0, and all of the things that it needed to fix, trying to understand, what kind of files to touch and etc. Whilst V0 is doing its own thing, because V0 can also take some time, because V0 is a different model and it has thinking and all that kind of stuff. Let's take a look at what happened before this. So I have a few other tests here that happened. So as you can see, did exactly the same thing, sent a message and ran tests and all whatnot, especially that I'm kind of out of time, but you can see it called, V0. So I'm going to go to a different version of this. So I have a 2.5 and a 2.6. So the 2.6 is like a retest, just to make sure things ran, because for performance tests, you normally want to do more than once. You don't want to do, especially with agentic behavior, we want to make sure that this kind of workflow actually works. So let's take a look at the difference. So this is the same sequencer within this run here that you're seeing right here. So it's the same sequencer. But now with the fix that DevTools sent the telemetry data to GPT-5, GPT-5 digested it, sent to V0, V0 fixed, and let's see how it will compare. So now we're going to do the same. We're going to run another trace, and let's do the trace because I clicked as the trace was capturing. So let's do again. Initializing. Okay, now it's tracing. So click, 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 just random clicks. And let's see how the interactions work. Okay, so now we have the actual results. So we went from 201 milliseconds. So I can zoom in again on our interaction event. So this is our interaction event, INP breakdown. So 155 milliseconds processing duration total. So we went from this to this, 56 milliseconds, entirely autonomously. So we now have an interaction event that has 56 total milliseconds. It has processing duration is pretty much none. So it's just mostly a pointer down and then a pointer call and then a function call. So basically what it did is within the event is not doing any kind of call execution per se. It's mostly just processing event. So it's not trying to do any React render work as the interaction event happens, which means the interaction event happens instantaneously. And the render, now most of our time is to process presentation delay, but it's still the entirety of the event lasts less than our threshold. So we have 13 milliseconds plus 50 some milliseconds here, 56 milliseconds, and then the 43 milliseconds total. So 56 milliseconds, sorry, is the entirety of duration. So input delay, processing, and presentation delay. And this is much better because now from when we click on the button to when we have that frame being shipped is a total of 56 milliseconds. So this was entirely done autonomously from DevTools. Us recording a trace of DevTools and then going to our code editor and asking it to fetch data from DevTools to then forwarding the data to our own code agent. It couldn't even be within Cursor. I just went through the troubles of doing within V0, so it is entirely agentic, quote unquote. So it's entirely generated code. So it's not a human. The human in the loop is just coordinating the agents. So this is like kind of like a peek into autonomous workflows and how you can connect different parts of an ecosystem to have a better result. Because if you go to V0 and ask to fix performance, it might go in an entirely different tangent because it is very keen on trying to fix things. So that was the demo. And V0 seemed to manage to fix things here. Well, at least process it, but unfortunately we have not the time to go through that, but it would be a similar situation because you already got all the data you needed to run those.
Perfect. Thank you so much, Vinicius. I wanted to see like if there is any question to Vinicius. We have kind of 5 minutes. So we have one question from Giri, actually. Do you want to read it?
Where's the question? Sorry, can you read it for me?
Okay. Do you hear me?
I do hear you, yeah.
Okay, it seems like Giri is not able to hear me, right?
Okay. You can write the question as well if you prefer to write.
Yeah, I can say it actually. So he's asking, is this MCP especially designed to address INP, or can it also provide insight context for other impacted metrics such as CLS or LCP?
For this demo, I've done so as you can see, the tools available. I didn't show the parameters, but it has INP, long animation frames, because long animation frames is kind of my thing. I've done a lot of talks around it. But it can also do other types of performance analysis. So it can very much, because I'm hooking straight into the internal agent ecosystem within DevTools. It has access to all the different insights. It has access to CLS, LCP, network. It has access to the many different things, and I can right away say that that is a hack of my own. Like I forked DevTools and created that all of that MCP things to hook into the internals of DevTools to fetch all that information. I have a tool called Perf Agent, which I didn't have time to demonstrate here, but is a live environment with an agent that is specialized in performance that does kind of the same, and I'm building that kind of ecosystem around it as well. But the DevTools team is also building an MCP server that should be made available in the near future with similar the outcome is slightly different, and I'm benchmarking it and giving feedback, but it's kind of the same veins. But you would have access to all the different insights if that's
yeah, perfect. Cool. Thank you. Any more questions? But I just wanted to, this is for my own sake, like, can you share your, you said you built something, can you share it also in the chat, so if people are interested can visit and learn more about it? Super.
So I have this, and that V0 MCP is also publicly available here.
Perfect. Cool. Thanks. Cool. So there is no more questions, I assume. We have still 2 minutes, so.
If any, like, you can also feel free to reach out straight on X if you would prefer, or LinkedIn. Just you can look for my name and you should find. But like, this is direct link to my X profile. Feel free to reach out on LinkedIn as well. Like whatever forms of reaching out there might be out there.
Yeah.
In person, if you bump me on around Central City.
Yeah, that would be great. Cool. Perfect. So I will share my screen again. I will, let me try to find the right window. Hopefully you see my screen, right? Okay, cool. So we are going on a break. Go grab a tea, a coffee or something. I need my coffee. So then we are back in 10 minutes. So, and then we will jump to the next talk, which is by Meghdad, and it's related to AI and AI bots and how we can improve our job search. Cool. So see you in 10 minutes. Okay. Post a message if you are back. So we will start our next session or next talk in like less than 30 seconds. Cool. I'm really excited to learn about AI and how can I use it on like solving my personal solutions or issues on daily basis we face. So excited. Oh, okay. Cool. So now we are going to the next talk, and it's Meghdad. Floor is yours, Meghdad.
Yeah, sure. Just let me share my screen first. Okay, now I have the same problem. I guess you have to stop sharing.
Oh, right.
Yeah.
Sorry. Now you should be able to steal the screen.
I think so. Let's see. Let me know when you see my screen.
Yes, it's visible now.
Great. Hello, everyone. Thank you so much for being here. And thanks a lot to Vinicius. That amazing talk. Very inspiring. And the next talk would be almost in the same topic, not exactly about performance, but about solving your day-to-day problems and issues using AI agents, but in a different way. My name is Meghdad. I'm a software engineer at Post, based in Stockholm. And honestly, I've always been a bit obsessed with automation, and lately the package of AI plus automation, and not in a take over the world way, but more in the let's make our lives easier way. If you want to know more about that, please stay in the talk. So one of the real life problems I wanted to tackle is job searching. So today is the day we're going to walk you through a project I've been building recently. It's called the Job Search Assistant. A very simple naming, as the idea is, and it's going to answer the question: what if you had your own personal team of HR, or let's say AI powered HR, guiding you through the whole entire job hunt process. But let's start with the problem first. If you have ever been searching for a job, which I guess most of us have, you know how overwhelming it can be. You send the same CV everywhere. You rarely get meaningful feedback from the employers, and it's hard to know what's working or what's not. And on top of that, tracking applications and tailoring cover letters can become a full-time job. So the pain points are: it's overwhelming. It's hard to track. CVs are not tailored, and it's difficult to keep up the pace because of disappointment, usually. So the solution
Sorry,
is
sorry. Before going to the solution, we have a hand raised, Zohre.
Yeah, I just wanted to mention that his camera is off, so.
Thank you. So the solution is a multi-agent system that uses AI to guide job seekers through the entire process. Each agent has a specific role One is the CV analyzer, another one helps with the job search, another helps with applications, and so on. And they all work together. The magic is in continuous conversation loop, as you can see in the recorded video on the right side. This is just in case if our live solution doesn't work. But we're going to see something live in action, of course, at the end of the talk. We chose the Telegram interface since it provides really easy to work and interact bot interface. And you talk to the system through Telegram. It gives you structured options, and you can always take the next step naturally. But we're going to see more details in next steps. Now let's take a step back and talk about what an agent actually is. In simple terms, an agent is an autonomous software unit. Each one is specialized to handle a single responsibility, like analyzing a CV in our case, or managing a profile. And agents can communicate with each other through this framework we're gonna introduce a bit later. And they can make decisions based on shared state, which allows the system to feel fluid and intelligent, rather than just a series of disconnected scripts or a chat to ChatGPT AI chatbot. But to build this, we're using Google's ADK, which stands for Agent Development Kit. You can think of it as a framework that helps you build intelligent agents in a structured, scalable way. Instead of cobbling together scripts, you get clear building blocks from ADK. The core pieces ADK provides you are basically agents, modular specialists like planners, orchestrators, or reasoners. But we use LLM agent. We're gonna talk about that later for reasoning, and sequential agent in this example for orchestration between the agents in our workflow. We're gonna use the tools. It's a way to for agents to extend their abilities, such as calling APIs or searching the web or running code. And memory and state, which keeps the system context aware across the whole process. And on top of this, ADK provides advanced orchestration styles like sequential, parallel looping, or even dynamic routing with an LLM. It integrates tightly with Google's ecosystem, but also supports open models as well. So you're not locked in, so to say. And here's what it makes a bit different from many other agentic frameworks. It's code first and multi-agent native. That means it's developer friendly, easy to version control, and designed for complex teams of agents working together. It also has built-in evaluation, logging, and guardrails for safety. Those are the things you often have to bolt on yourself in other frameworks. But in short, ADK gives you a solid production-ready foundation for building and running agentic systems instead of reinventing the whole wheel. But one of the most important things to emphasize here is the two-way communication between the agent and the bot. And this is made possible through one of ADK's features called the output schema. By defining a clear output model and giving it to the agent as the output schema queue, we can ensure that responses are predictable and more importantly, structured. And why is this so powerful? Because Once the response is structured, we can easily integrate it with other software systems. In our case, the goal was to avoid forcing the user to type prompts in the Telegram chat. Instead, the bot would generate inline keyboard buttons in Telegram. So the message key, as you see in the model here, would come from agent to the bot, and the bot will show this as the main message text. And then the options, it's an array of strings. It will turn into clickable buttons, and the agent itself proposes the next meaningful actions, and the user just taps them. That's how we move from free text prompting to guided button-driven experience. A little bit about implementation detail. So the way we implemented this is like this. At the entry point, we have a root agent, which is required for this kind of systems in ADK. That's one of the main rules. I built this root agent using something called sequential agent, since its job is only to pass work step by step to other agents. And as you can see, there's a description field that describes what this agent is supposed to do, which is one of the most important parts of designing agentic systems with ADK. We're going to talk about that a bit later. Inside the sequence, we placed a coordinator agent that plays the role of our switchboard. It takes responsibility for routing tasks to the right specialist, our HR team of sub-agents. Then we added another agent whose only role is to transform the previous agent's response into the schema we defined earlier. This schema agent reads the structured output from the coordinator from an output key called unstructured output. So as you can see here, this is the coordinator agent that was instructed to export the response it prepares for the user or for the next agent and put it in an output key called unstructured output. Once the next agent in the sequence, the structured response, receives the unstructured output, it will act on it based on the instructions it has been given. To make sure the schema agent has enough context to generate useful options, we instructed the coordinator agent to put potential next actions inside braces, like analyze my CV or search for jobs for me, or these kind of options that will be generated by our coordinator agent, be given as unstructured output to the structure response agent. This way, the schema will be clean enough for the bot to understand it in the next steps in the process. Now, let's look at the first agent in our workflow. It's called the file extractor agent. Its only responsibility is handling CV files. Here's how it works. As soon as the user sends the CV file through Telegram, it checks out the database. If the CV file content wasn't exist in the database, it would extract the CV file content from the PDF file and store it in our state or our database for next group of agents to act on it. But how does an agent actually interacts with a database? This is where ADK's tool mechanism comes in. We define simple Python functions as tools, and for this agent, for example, I created two tools, one of them searching database for CV content and another one responsible for saving new CV content into database. And the agent doesn't call the database directly. Instead, it gets a tool context passed to the tool function. When the agent calls a tool, it either fetches data from the state or writes data into it. From there, the tool context ensures it's persisted into the database. And the important part here is the tool description. As designer of this system, we need to describe each tool clearly, because the agent uses those description to figure out when and how to use the tools. In other words, the intelligence is guided by how well we define the interface. This is the same. This is the same case for agents. When you define a new agent, you have to be super clear about your instruction about what you want this agent to do. And you have to be able to draw the line between the agent's responsibility and domain, so the root agent doesn't get confused for delegating the task to the next agent in the sequence. The next important agent we have in this agentic group is called CV Analyzer agent. This is a fairly simple LLM agent, but we gave it very precise instructions on how to produce the type of report we wanted. So for like in this case, you won't be able to see all the instruction because it's pretty long text, but you will be able to check the code out in the GitHub repository we're going to share with you later. The agent, this agent is not only responsible for analyzing the CV, but it also checks the candidate's personal branding online. And to do that, we connected it with a Google tool, as you can see in the example. This is a built-in tool provided by ADK. So it can look up the candidate's digital presence and provide a short summary of that. And once that's done, all results are stored in the database through the same tool mechanism I described earlier, which ensures that later agents can access the insights. So next, we have the job search agent. Its job is to take the CV analysis from database and use a LinkedIn search tool we provided to look for relevant job posting. After that, we run the result through a sorting agent that ranks them accordingly to how well they match the candidate's profile. And they all then put together in a sequential agent called CV Analyzer Parallel Agent. I mean, sorry for the naming. It was supposed to be a parallel agent, but then during the process, I changed that to sequential. So this CV Analyzer agent, the sequential agent, is the one will be handling everything related to CV analysis. So challenges with the ADK, because it wasn't all that easy at the beginning. There was definitely a really strange learning curve to that, despite my expectation. In practice, getting started with ADK wasn't that hard, but one of the biggest challenges was timing. ADK was fairly new, so the documentation was limited and the community was still new and small, which meant that often we had to rely on trial and error. And another challenge was the differences between the ways you can run your agent. And by default, you can run an agent in the terminal and start chatting with it in your in a terminal-based application, or spin up the ADK web interface and interact with it in the browser, like what you do with ChatGPT. But in our case, we wanted to connect the agent system to Telegram. And to do that, we needed to expose APIs from ADK so our bot could talk to the agents directly. The side effect of this approach was that many conveniences the web UI gives you automatically, like session management and user management, we had to implement everything ourselves. But it took some time for us to understand this. But it also gave us much more control over the system. That took a while due to lack of proper documentation for such case scenarios. Another challenge we faced was the speed. Communicating with the agent team through APIs sometimes made responses slower compared to using the built-in ADK web UI, which can be faster. But this became especially noticeable when connecting through Telegram, where users expect quick responses. We also struggled with choosing the right agent models that ADK provides. Deciding when to use which Gemini model to balance the speed and accuracy was a trial and error process too. What's next is actually we can try to look at the solution together. I tried to run both the web UI and Telegram interface for you. You just need to change the screen. I'm sharing.
Remember, just as a reminder, you have 4 minutes. So
I'll be done very soon.
Perfect. Thanks.
Entire screen. You should be able to see the screen now. So let's try it out here. I'll just try to zoom in. The left side is our agent application, and right side will run our bot, Telegram bot application. We're going to run ADK through a API server to have it expose APIs we require for the bot to interact with. And once the connection is established between the bot and the agent, it should be able to send messages, which will start with just this start command. So as you can see, the job search assistant responded almost immediately back to the Telegram. And this is what I was trying to make clear in my presentation. So instead of writing back to agent, you can choose or can click on the inline buttons that was created through this output schema we defined for the agent. I'm just going to go ahead and share my CV with the agent. I hope that doesn't take a lot of time. It can be very slow sometimes. So the bot will react to your message as soon as it could initiate the conversation with the agent in the background. And as you can see, there are things being done on the agent side. There are functions and tools being called. Like this, in this example, it's calling the set user CV file content, the one we mentioned in the presentation earlier. And through this tool calling and function calling, the bot, the agent is actually being trying to be to keep the context up to date so that next agents can use the data saved by the first agent. This is the problem. One of the problems I mentioned, the speed will decrease a little when working through Telegram bot, but it's worth a try. I hope it doesn't time out at least. The bot is receiving the events from server, and hopefully something will show up very soon. Okay, nice. I didn't expect it to provide the CV analysis that soon, but good that we didn't have to wait much. So as you can see, there's a detailed analysis that was done based on very detailed instructions we gave to agents. And you can go through all the detail when you try to run the agent yourself, but it's good to see that there are two other options suggested by the agent after your CV analysis is done. It's either search for jobs or improve my CV. We're not going to be able to go through the whole process now, but I hope you can you have the time to check out the code we're going to share later in this chat and try it yourself. And hopefully this can help you guys to solve your job hunt issues and your day-to-day life. But yeah, feel free to ask questions if there are any. I think I was
Perfect. You were on time. Thank you so much for this great talk. I think I need to use this AI for myself also. So I'm interested to see the code base and maybe pull it on my local and give it a try and use it. Do we have any question? Like, I think we have only for a short question, one or two maybe. But in the meantime, I will share my screen again. We have that Menti thingy that I told you. We have to, let me share my screen. Okay, I hope you see my screen. I'm also gonna try it. Please use your mobile phone if you want to use your use it on your mobile, or just I think we can share the link also in the chat, so we can all share our feedback to the event we had. And yeah, let's see how many people are joining. I can also, I think I can share the link in the chat. Let me try to find it. Sorry.
I did.
Oh, perfect. Perfect. Thank you. So since we have the link and also we showed the QR code, I think maybe Zohra, you can share your screen. I am stopping my screen again.
Okay, I can see my screen.
Yeah, we do see it.
Good.
Let's see how many people are joining. Cool, we have 14 people joined. Since we have, I think, 4 questions, right? I think we can wait a bit and then, yeah. Let's go to the next question. Cool, I can see that participants are typing, so let's give it a few more seconds. Yeah, I can also read this, like 20 minutes is a bit short. Yeah, of course. We are trying to like increase the talks duration, maybe next time when we have our in-person meeting. But thank you so much for the feedback. Okay, cool. So maybe the next question. Yeah, I think all of us, we have worked all the day, right? Maybe we can find a better time next session. Perfect. I can also thank you so much. I can see that still people are typing, but thank you so much. I just give me a sec. I wanna reshare my screen. So okay, I can also share the link of our chapter on LinkedIn. Feel free to join and just share if you have any idea, if you have any question, if you need to see something more. But yeah, just feel free to ping us right in our comment section. And also just to give a heads up, we are looking for speakers, volunteers, and ideas. So if you have something, if you want to get involved, reach out to our organizers. And also remember that this is just the beginning. We will have more events, hopefully more in person, to meet you all and maybe do a networking session and yeah, learn from each other. Thank you so much for being a part of our Kickoff, and hopefully we are going to see you soon again. Thank you.
Thank you, everyone.
Thank you.
Thank you.